In this video, we're going to learn how to make it so our player can only jump when they're actually on the ground. I'm going to start with a little bit of recap of what our player movement has right now first. I click the play button and go into the play mode so I can move around a little bit. Right now we've got a character who can move with either WASD or arrow keys, and then press the space bar to jump up like this. The player component has a couple settings on it where I can adjust these. Whether the move speed or the jump force is what I want to change, I can do that real quick. And then we have the code right here that controls it. I made a couple of adjustments for this video, but the main thing we have are these two variables right here, the move speed and jump force that I was talking about earlier in the inspector here. As a recap, these are both floats because that lets you adjust a number with decimal points. And by having these be private, what that means is only this script can access these variables. For example, if you had like an inventory script or something on your player, you might have something else that needs to access that inventory. If you made your inventory private, no other script would be able to access it. And so you'd want to make it public instead. And I'll talk about more about that in the inventory video. But this serialized field here, basically, if you have a private variable, you also can't see it in the inspector. But sometimes you want to see it in the inspector, but still have the variable be private. So this serialized field value here says the move speed is private and only the script can access it, but you can still edit it in the inspector. And then we have the same thing here for the jump force. Whenever you have some sort of setting for your character, what I've been telling you in the past to do is just make it public like this. But technically, the correct thing to actually do is make it serialized field private. That's the best pattern because you want your scripts to be as simple from the outside as possible. I'll get into more about that later. Really, it doesn't matter if it's public or serialized field private. I just wanted to explain that serialized field thing really quick. We also have a private float for our movement and a private rigid body called _RB. Notice these are not serialized field and they're not public, which means even though these are both values that the script is using, you can't see them in the inspector. If you want to see them in the inspector, you can click the ... and then go to debug mode and see the values here. You'll see they're both grayed out because they're supposed to be hidden. But if I play the game, and you give it a second, and you give it more than a second, you'll see the values get assigned. So we have movement still 0 because I haven't started moving yet. But RB is set to the player's rigid body 2D. If I move, you'll see movement changes. Using the debug tool is really, really helpful for debugging these private variables because the alternative would be to just make them public temporarily, which is okay, but this is a lot better because you don't have to change the script and then change it back. Next, this rigid body 2D is how we're moving our character. And I want you to really focus on the components that are built in Unity because they're really important for knowing how to create a behavior. Moving on from just watching and following tutorials to actually creating scripts on your own can be a big daunting step. So it's really important to understand the built-in components in Unity and how you can manipulate them to do what you want. If you ever want to learn how to do scripts without following videos, which most of you probably do, that's basically the first step because Unity has all of these built-in components like rigid body and box glider. You have to memorize what each one does and think about from the perspective of what you want your script to do, what component would do that best. For example, box glider. This is a physics-related component, but it doesn't add physics to the object. It adds collision to the object. So you'd put it on something like the ground that needs collision, but no physics. And then on your player wants collision, so you give it a box glider. But you also want physics, so you give it a rigid body 2D. And that's the first step to understanding how to make a script from scratch. Is what components does my thing need to do? And then what do I need to do with that component? Because if we're not even talking about coding right now, we're talking about logic. How do you make a player move? This is a part that you can't really teach. You have to kind of just intuit and practice it over and over again. How do you make a character move? You can't just say they move. You have to figure out the underlying thing that causes it to move. For example, it's the physics. To make something move, you have to apply velocity. Once you understand you're applying velocity, then you ask, what component allows me to apply velocity? Oh, that's the rigid body, because it's a physics component. And that's the first step to making a script from scratch. So back to the code here. That's why I did a private rigid body underscore RB, because I wanted to get the rigid body because I knew I'd have to manipulate my character's velocity. Now, if I made this a public rigid body here, again, either public or serialized field private is going to let me assign this in the inspector instead. And this has a pro and a con. The pro is that now I have this slot here, and I can drag in the rigid body like this. One, it makes it a little more clear that this is the player's rigid body. Two, I could actually drag in a separate object's rigid body if I wanted to. And those are kind of the two positives there. Like you can physically see it says player rigid body 2D. So I know that this rigid body here is the player's rigid body right now. And any lines that affect its velocity will affect the player's velocity. But every time you make a platform movement script on a player, like let's say if I had a second player like this, I'd have to make sure that both players have the correct rigid body. And that's really annoying to do. You basically, whenever you make a script, generally, you want to have the least setup needed. If my script is an inventory script, for example, the things I'd want to set up with an inventory from a design standpoint might be the max number of items you can hold and the button it takes to open and close the inventory. But I wouldn't want to have to customize what UI it's plugged into every single time because that would get really annoying and tedious. So back in this platform movement script, instead of making it a public rigid body, make it a private rigid body. And in our private void awake, our very first line says underscore RB equals get component rigid body 2D. What that means is we're going to get the rigid body 2D on this object, that's what get component does, and assign it to the variable. So no matter what object this is on, as long as it has a rigid body 2D, that invisible RB value here is going to be set to its rigid body. And you can't ever change it, which is a good thing. Like 99% of the time you have a platform movement script like this, the rigid body should just be its own rigid body anyways. There should be no reason to ever want to change that. And we have update, not fixed update. We have update where we set our rigid body's linear velocity x equal to movement. Again, part of understanding how to make a script from scratch is knowing what needs to change. And that's not even a coding thing. That's like a design problem. How does a character move? Its velocity. You don't have to really even know what settings go on a rigid body. You can just start typing and see what pops up. Like if I say RB dot and I type in velocity, I'll see a few things pop up. Angular velocity, linear velocity x, linear velocity y. It could be any of these bottom three really, but you have to think about it. Linear velocity here is a vector 2. What that means is you get to set the x velocity and the y velocity at the same time. Linear velocity x here is a float. And based on the x there, you should be able to figure out that it's on the x-axis, which as a reminder is left and right. And then linear velocity y here, as a reminder, is on the y-axis, which is up and down. Hopefully your player moves on the x and y x-axis. Maybe it doesn't. It might be a different game. I don't know. But I'm going to do linear velocity x for this. And then in my move function here, we are assigning this movement variable to the x value of whatever our current like stick movement is. Basically, your control stick can move up, down, left, and right, which means that it's a vector too. It has an x position and a y position. Like if I'm holding the stick all the way up, the x position is 0 and the y position is 1. If I'm putting it all the way to the left, the x position is -1 and the y position is 0. So basically I'm saying, get whatever value my stick currently has, and then get the x from it. And then multiply it by that move speed variable I mentioned earlier. We're assigning this to a variable called movement that we use in the update function. Now, in an ideal world, we wouldn't need movement. In an ideal world, all we would need to do is say underscore RB dot linear velocity x equals move speed like that. But the problem here is that Unity only calls this function when you start and stop the input. It doesn't call it every single frame like it should. And there's no way to change that. So you have to kind of annoyingly read the input and move and then apply it and update. It's kind of weird. Again, this function will only get called when you press and release the button, which takes us in a jump here. because I mentioned it also calls when you release the button, which you clearly don't want when you jump. So this little line of code here says, if the input was canceled, aka you released it, then return, which means don't do anything else. So if you release the button, don't do anything else. And the anything else is setting our y velocity to our jump force. Again, if you're moving left and right on the x-axis, then you're probably jumping on the y-axis. That's a little recap of the script here. Back to Unity, we've got our player with the player input component here. I mentioned our player had a box slider and a rigid body as some of the components. It also has a sprite renderer, which controls its visibility and what it looks like, and a player input component, which is what lets you actually give it input from a keyboard or a gamepad. If I go into events and player, you'll see two of them are assigned, the move and the jump. That's because I have a move and a jump function in my script. But if I made one for run or attack or look or something like that, I could make more functions and plug them in, which is the next step. After you make the code and you find the move and the jump and everything, you have to plug it in, which is like creating a new Unity event by clicking the button here and then dragging your component in and then saying what you want to do. Now, this is a very decoupled system. What that means is that pressing the button and reacting to the button press are completely different things. Again, all you're doing is plugging the two things together, which means you can do anything. You have anything happen when we press this jump button. Or like this attack button here. I click the plus button and I drag in my ground object and then set game object set active and have this unchecked, which means false. That means that whenever I hit the attack button, it's going to set the ground object to be gone. It's going to go away. So you can have anything happen when you do these button presses. But by plugging it into the functions that we have made in our script, and specifically functions that say input action.callback context ctx inside these parentheses, it allows you to get special information about the button press. Anyways, that's just a big recap. I recommend watching the original video. I changed a few things, which is why I did the recap. But this video is clearly about how to do jump and how to make sure the jump only works when you're on the ground. So this video is going to cover a bunch of cool things about that. Apologies for the very long opening there, but we're going to actually get into new stuff now. Basically, what we need this script to do is create a box under the player's feet and see if the box is touching something. This is called a box cast. Now, there's a few ways you can do this, and this video will go over the simplest way and the most easy to customize or whatever. But we have a player here, and the end goal is to say, draw an invisible box under the player's feet. And if that box is touching something, they're on the ground. If not, then they're in the air. For example, if my player here is on the ground, oh my gosh, weird. It's on the ground and it draws that invisible box, then that's good. We're on the ground. Now, clearly here we're not actually on the ground, which is why we're going to make the box size very, very customizable. In general, I'd recommend a very small, very thin box like this. But anyways, let's get into it. In our existing movement script here, we're going to add a few things. We're going to add, first of all, in our jump function, we're going to check to see if we're on the ground before we apply our jump. But before we do that, we need a way of figuring out if we're on the ground. So we're going to make a new function here. We're going to make it a private bool called isGrounded. Notice the syntax here. Private means it's only accessible in this script. Bool means that whatever we write inside of these curly brackets is going to somehow give us a true or false value. And isGrounded is how we're going to call this function, is what it's called. Now, if you end up hearing that, my cat's working, just ignore her. Anyways, these parentheses mean that we're creating a function that we can call. Every time we call the function, it's going to run all the code inside of it and then evaluate it and give us some sort of return. Basically, I'm going to write some comments as I go to help document our code a little bit, but also so we have kind of a step-by-step thing of what we want to do. I'm going to write the first comment that's going to say, check for the ground using a box cast. Next thing we're going to do here is I'll show you what a box cast is. To create a box cast, you write physics2d.boxcast like this. Boxcast is a function like one we're making right now, and what that means is that it takes in certain inputs and gives you an output, like in math, a mathematical function, f of x equals whatever. Like in math, if I had a function that said f of x equals x plus 1, the function would return whatever x is plus 1. What this function is going to do is it's not going to take anything, but it's going to return if we're on the ground or not. And the physics 2D boxcast function takes a few parameters and will give us something called a raycast hit 2D, which tells us what was hit in great detail. First thing we have here is our boxcast origin. We're just going to start by saying transform.position for our origin, which is going to get the position of our player. Then the next thing is our vector2 size. For this one, we're just going to start by saying new vector2 here, and then we're going to put an x followed by a y. Our x I'll say 1, and our y I'll say 1, like that. Then we have an angle, we're just going to say 0, and a direction, we're going to say vector2.0. This is the most basic boxcast you can create, and the next thing we're going to do is just return whether or not the boxcast hit something. We're going to say, actually, before we do that, our boxcast here, again, this function takes all of this, and it's going to give us something called a raycast hit 2D. In order to get information from the raycast hit 2D, we need to turn this into a variable. So we're just going to say raycast hit 2D hit equals physics2d.boxcast. Now we have this hit variable here, and we can get information from it. Like I could say debug.log hit.collider.name, and that would give me the name of the object that my raycast hit. And I'm actually going to keep this here because this is going to be very helpful later. The next thing, if I do hit dot, you can see a bunch of information here. The rigid body that was hit, the normal of the collision, the distance of the collision, the transform of the object that was hit, the centroid, a bunch of random nonsense that not everyone's going to understand. I honestly don't even know what all these things mean. That's fine. I've never used half of these before. The big one that you're going to end up using is just collider. Hit is actually kind of an interesting type here, raycast hit 2D. This is called a struct. And what that means is basically Unity was able to create their own custom type, and anyone can create their own custom type using a struct. Technically, your classes, your components, they're all custom types. But if I control click raycast hit 2D, it'll actually tell me all of the like internals of this type. Like I can see all these things I was looking at earlier, but they kind of look funky because we're looking inside of it right now. An interesting find is if you scroll all the way down, we have it right here. It's a public static implicit operator bool, blah, 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 blah. This part's kind of complex, so I'm not going to really explain exactly what it means. But basically, this just says, if you just use the raycast value, this hit thing here, it'll actually become a boolean, aka a true or false value. So if I just say return hit like that, this will return true if the raycast hit something and false if it didn't hit something. And that's what we want the function to do. True if it hit the ground and false if it didn't hit the ground. Notice that hit the ground and hit something are different things. We only want to check if it hits the ground, and right now it'll tell if it hits anything at all. We'll get there in a minute. I just want to test this out real quick and show you how we're going to use this function. This function is not complete yet. We do have more things to add to it. But generally, when coding, it's kind of a good idea to work backwards. For example, in our jump function here, I know we're going to use the isGrounded. So we're going to implement the isGrounded into our jump before we finish writing it, because that's going to help us implement the function better. Right now, we have it in here where it says if ctx.canceled return. And like I mentioned earlier, that basically says stop doing the jump thing if we actually release the button instead of pressing it. We want to add another condition there. We want to say if the context was canceled, like you stop pressing the button, or if you're not on the ground, then return from the function. To add an or into an if like this, you do 2 vertical lines and then what you're trying to do. So this right now says if you cancel the button or if you're grounded, which is not what we want. We want if you're not grounded. So to do that, we're going to add a little exclamation point for the word is here. So now again, reading this in natural language, we're saying if the button was released or canceled, or if you're not grounded, then return. And logically that makes sense. A big part of figuring out how to write scripts is figuring out how to like deduce the logic behind it. Once you figure out what the logic is, then it's easier to write the code. Again, this comes from experience, and a lot of this is practice. Like when you make your first movement script, you're not going to know that you need a grounded check. After your seventh or eighth one, you're going to know, oh yeah, I should add a grounded check, or yeah, I should probably make these functions use input action callback context CTX or whatever. It all comes with practice, which is why I recommend watching all the videos. It gets very repetitive, but that's on purpose. Repetition is a really good part of learning. If you don't do something multiple times, you're not going to learn how to do it. So that's why there's so many of them. Anyways, let's test it out. This function, when it gets called, is going to also print the name of what was hit, and that's going to be a great way to know if the function actually gets called or not. Because when you have issues with your game, you have to figure out where the issue is coming from. The first thing we need to do is figure out if it's going to be the script or not. There's only a few more steps after this, by the way. We're basically almost done. You give it a minute to load. And then it's going to take another minute after I hit the play button. As long as we don't run into the issue where it gets stuck on the player input actions thing, because then it will cause like an infinite loading thing. Okay, so we're going to run it now. And whenever you do a debug.log, that message ends up in the console window here. So I'm going to just open up the console window while we're at it. When I hit the space bar, you see it says player. Well, that's audited twice. Anyways, it says player. That means we know that the function works. We can actually see here it got called from the isGrounded function on line 41. I can actually click on that and it will take me there. Right here. This is great. This is what we want. Now, notice that we can still infinitely jump because our raycast or boxcast thinks it's successful because it hit something, because that's all we told it to do. We didn't tell it only hit something on the ground, which is what we want. But the question is, how do we differentiate something that's ground versus something that's not ground? You could check for the thing being named ground, but if you name it something else, that's not going to work. You could give it you could create a tag called ground and then give it that tag. But tags are kind of finicky, and an object can only have one tag, which is really, really annoying. So we're going to use something called a layer. Layers work really well with boxcast because there's actually a setting for it inside of there. What we're going to do is we're going to click the layer on ground, and we're going to change it to, well, we're going to click add layer first. And then we're going to create a layer in the first empty slot called ground, and then go back to the ground and change the layer from default to ground. Now we've created some way to identify things that are on the ground. This is really helpful because if you have something like a box, which needs a box tag, you can still put it on the ground layer and the game will know that it's on the ground. Back into our code, we need a way to tell the boxcast right here, we are only filtering things that are in the ground layer. Ignore everything else because we don't want to hit the player. We want to hit the ground. Before we do that though, we're going to improve this code here because this code is actually completely broken. The boxcast here is being spawned at the player's position, which means the very center of the player. We want to spawn at their feet. And the current size is 1 on the x-axis and 1 on the y-axis, which is exactly as big as one of these squares here, which is way too big. I mentioned earlier this should be thin. Now we could fiddle around with these values, try something very small for the y, and then small for the x, and then we could do plus new vector 2 here, and add some sort of offset. But this is really annoying, and we'd have to test this over and over again. So what we're going to do is we're going to, this isn't a real word, variabilize it. Basically, we're taking anything that we're hard coding here, and we're going to turn it into a variable. When you say hard coding, that just means you're kind of like making the code only work one way. It only works for this right now. We really, really want it to be more flexible. This code is not flexible at all. If anything in our game changed, it probably just would not work anymore, which is not what we want. So we're going to create 2 variables at the top, just like we did for our movement and jump force variables here. We're going to make one for our box's offset, one for its size, and one for the layer that we want to check for. So at the top here, we're going to scroll up. We're going to create some variables under here. The first thing we want is the offset, which is a vector 2 because we can offset it on the x and the y axis. So we're going to say serialized field private vector2 box offset. And then we're going to do the same thing with a private vector2 box size. And then we want to say that basically this layer drop down here, we want to create one of those and say choose a layer that this object can check for a box cast on. And that is called a private layer mask. And then it's called box layer. Now we've added 3 more variables to the script. We have a total of 5. That's all we're going to make. What we're going to do is in this box cast function here, where we say transform.position, we're going to say plus box offset. And then instead of new vector2 1 1, we're going to say box size. And then after this vector2.0, we're going to add a comma for another parameter, which is our distance, which is going to be 0, and then a comma, and then there's actually 8 versions of this function, which is really annoying. We have to find the one that uses the layer mask, which it looks like we just found. This one, layer mask, is right after distance, so it's going to say underscore box layer here. Now it's yelling at me because Unity stores all of its positions as vector 3s, which means they have a z value, even if your game isn't 3D. And you'll notice that because if I go to my player here and open up the transform component, you'll see they'll have z values here. So basically it's saying we're trying to add a vector 3, which has a z value, to a vector 2, which does not have a z value, and it doesn't know what to do. What we're going to do is just, before the word box offset, write vector 3, and temporarily turn box offset into a vector 3, so it'll stop being really confused about that thing. But this is good for the box is grounded function now. This is actually done. The debug log, we'll keep it here for testing purposes, but you could get rid of it now if you wanted. Typically, you only need these while you're debugging. But the boxcast function now says, create a box in the player's position plus some offset with some size at the angle 0, with the direction 0, with the distance 0. If I'm being honest, I don't know what direction or distance does. That's why I said it's 0 all the time. And then only check for things on a given layer. If I save and go back to Unity in a second, which is actually going much quicker than I did before. I think it's about to finish. You'll see our 3 new variables, our box offset, our box size, and our box layer. Let's start by changing box layer to ground. And then box size, let's try 0.5, 0.1. And the box offset, we'll keep 0 on the x, and we'll do -1 on the y. Now, this is great and all. This is so much easier to customize than just writing out random numbers here and hoping they work. But the issue is, we want our code to be very designer friendly, because not only are we programmers in this class, we're designers. We're trying to create a script that'll do something and then test it and improve it until the game is actually fun and not just functional. And it's really difficult to do that without being able to visualize things. There's a box that's being drawn here, but it's invisible. We can't actually tell. Boxcast doesn't literally draw the thing, obviously. It just imagines there's a box there. But we want it so if we're in the edit mode, we can actually see a little box where our box cast would be, so we can more easily test things. So let's do that. To do that, under our private bool is grounded, we're going to add a private void on draw gizmos. Now, if you remember from the other videos that you may have seen, if I put something in void start, it'll happen when the game starts. If I put it in void awake, it'll happen before start. If I put it in void update, it'll happen every frame. If I put it in void fixed update, it'll happen exactly 60 times every frame. If I put something in on draw gizmos, it'll allow me to run anything that starts with gizmos dot, and it will draw it inside of the inspector in edit mode and my game view if I have the gizmos box here selected. What we want to do is we want to draw a box that uses the same settings here so we can visualize our box cast. To do that, we're going to say draw wire cube. The first parameter is the position of the box, which earlier we said was transform.position plus vector 3 underscore box offset. And then our next parameter is the size. We'll say box size. So notice that this is an exact copy of this, which is what we want. And I should have just copy and pasted it. But they should be the exact same, because this should always be a perfect example of what this is. If I switch back to Unity now, you'll see that in the scene view, there exists a tiny box at the player's feet. And when I change these values, the box changes in real time. Again, this is essential for being able to test this thing out. Because if it doesn't work, I don't want to randomly guess and change things. I want to be able to see on the fly how big my box is. Now I only have to change it once. I'd never have to worry about ever again if this is going to be the right size. And if the game changes and my player becomes wider, for example, I can change the box size and oh my gosh. And in 2 seconds now, I know exactly exactly how big the box is relative to my player. It's super easy. Anyways, quick recap. Okay, this is grounded function that returns a boolean. Every time I write is grounded in my code, which happens right here, it's going to run this code and then return this value. And this code is going to draw a box at my feet and return if it actually found something or not. And then onDrawGizmos just visualizes whatever I did here by manually saying draw a cube at the given position with the given offset with the given size. We didn't change anything here, but we did add a few more variables here, which are not technically necessary to make this work, but are necessary if you don't want to lose your mind while testing it. One thing I didn't mention is this little line up here. If you write require component type of above your class, you can make it so your object needs a given component to work. For example, on line 15, I'm defining a rigid body, and on line 19, I'm saying to get that rigid body. If my character didn't have a rigid body, it would freak out. So this require component says this object literally needs a rigid body. If it does not have a rigid body and you add this script to it, it'll give it one. And if you try to remove that rigid body, it won't let you. After the word type of rigid body here, I can do a comma and add more. I also want to say that everything with the platform movement script is going to need a player input component. You could add more things too, like you could say it needs a box collider 2D. But I prefer to add things that only if the script literally requires them. Like the script will work without a box collider, so I'm not going to put that there. But the script wouldn't work without a rigid body, and these two parts rely on it having a player input component. So we're just going to keep it at these two right here. This should be all good. I feel bad for only having one part be commented, but whatever, it's fine. I haven't explained comments yet in my videos, but basically if you type in 2 slashes, you can write whatever you want and the code won't try to compile it, which means that you can write human readable text that would normally crash your game, or you can take code that you don't want to use anymore and you can temporarily disable it. Back to Unity here. All the variables here are good. This object is on the ground layer and it has box collider, which is really important because the box cast will only check for things that have colliders. So this should be good. Let's test it out. So I didn't make any changes to movement, so I should still be able to move. And grounded is true, so I should be able to jump. And if I'm in the air, I should not be able to jump again, which I cannot. Now it is giving me an error, which we should check out. But everything here seems good, aside from the error. Let's actually check it that, because I didn't think that would happen. If I double click it, it says it's on line 44. If I double click it, just take me there. Line 44, that's actually a really good example. It's saying that object reference not set to instance of an object, which sounds like garbage. That's hard to understand what that means. Basically, that means an object was null and you were trying to use it. Now, an object is null means that you tried to grab a value from something that didn't exist. Like if I had a function called find nearest dog and there weren't any nearby dogs, and immediately after that I said get the nearest dog and then get its name, it would say there aren't any dogs to get the name of. That's what's happening here. It's saying there are no collisions to get the name of. So this debug log here is breaking our code. We could say only run the debug log if it hits something, or we could just get rid of the debug logs. We don't need it anymore anyways. Basically, if you're ever writing code that needs to assume something, don't. That code was assuming the box hit something, which sometimes it won't. Or you might assume the player has a rigid body, which it might not have. So you want to write code with if statements and things like that, or require components that will take away assumptions for your game. If I play the game now, hit the space bar to